we get these things that are called, what are called points of concurrency. Points of concurrency is a fancy way of saying where three or more lines intersect. A place
Are you making this short project?
Yeah. Yeah. Point of concurrency is basically, you want to think of it as a place where three or more lines intersect. What happens is, when we talk about our triangles, we have a couple of different things that are called concurrent, and they're points of concurrency. Excuse me. They have specific names. So if we understand what part matches with what, like we said earlier, the mathing is really simple. So the idea today is we're working with what are called our different bisectors, whether that is second bisectors, angle bisectors, and perpendicular bisectors. So first one we'll look at is called the circumcenter. So again, this is really weird. This is, what's that? Yes, sir. This is one of the ones we're going to look. It's where perpendicular, excuse me, bisectors intersect. Okay. The circumcenter is where perpendicular bisectors intersect. And I'll draw another picture of that off to the side.
You know what a relation is?
I do. I agree.
Make sure you guys have a picture drawn for every vocabulary.
So we have to draw one.
There's only 3 triangles. You're good at that.
You made it sound so complicated. Wow.
You want someone to go on like a draw.
You know what? You're right.
Oh, sorry. What happens now with these, what's called the perpendicular bisectors, within each one of these, what we call circumcenters, there's going to be some part that happens to be congruent. And when you have this circumcenter, the place where the perpendicular bisectors intersect, the part that's congruent, it is from the point to vertex are congruent. Now, what I mean by the point, I mean by the point where they intersect. So it's point to vertex are all congruent. So on my diagram that I draw, I would draw from here to here.
We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What are you looking at?
You know how many triangles?
Oh, no, I'm not worried about that. Instead of, you remember how we call these guys all the perpendicular bisectors, and I marked it with 3 tick marks, 1 tick mark, 1, 2 for all the bisected parts here? What I'm going to do with these 3 pieces that are congruent, I'm going to make like a little V. That means that those guys are congruent. So it's the point to vertex are congruent. Point to vertex are congruent. All right? And I think, Ms. Rory, we can attest that we like to try to make it as simplistic as that. If you know that you've got circumcenter, point to vertex, it's congruent.
So do you see how Mr. Murphy was able to, with the color, with the white dot markers, have that shown in a different color? If you have a highlight marker, this is definitely something I would highlight. Nice job. I see it. Very good. Okay.
Flip me off. Putting out a little car wreck since you flipped me off when you tried to make my break. I was going to say, all right, so again, circumcenter, point to vertex, and they're the perpendicular bisectors.
I just need color.
Ungrateful.
I know.
Sure. All right, so far so good?
Yes, sir.
All right, we got another one. In center. In center. The in center is where the angle bisectors meet. The in center is where the angle bisectors meet. It is where angle bisectors meet. Okay, draw that one.
You know, if someone's changing colors, we could. Really, each one of them.
Yeah. And these guys are all
No.
it's the point to side are congruent. Okay? In the in center, it's point to side is congruent.
I got Mr. Bouchard.
All right? Every time we call it a point, we're talking about where that point where they meet. Is that a place of congruency? One thing that's real fancy term-wise. And point to side is what is congruent. All right? Point to side. Point to side. Because it's in the center.
I didn't even put it up.
As we get into it, Burnish. Okay? So far, so good? All right. And I think, now here's what we were saying about knowing your vocab. In this example here, it says you have an in center. What segments are congruent for an in center? Point to side. So I know that all of my point to sides are congruent. So if I'm looking at my picture, I know that from here, these three pieces would have to be the same. Okay? All right? So by knowing the vocab, I then know that if I have GE, which was this segment here, was 2x minus 7. And the GF, this guy down here, was x plus 4. Okay? What do you do? Exactly. So you know what to set equal to each other. Okay? Then you can get your algebra then. Shh, gentlemen.
So she uses technique. X plus 7.
Very good. Using the vocab by saying that, oh, that's an in center. Since I know that it's an in center, that means all the segments that are from the point to side are all the same. So algebraically, when they give me stuff, I know that I can just set those two equal to each other, and you get x is 11. Now the problem, though, it doesn't say just solve for x. The problem says
Solve for GD.
right. So GD has to be the same thing as GE, which has to be the same thing as GF. So what's 11 plus 4? 15. So they're all 15. Bless you.
That's crazy.
Bless you. Bless you. Bless you. No? Yes? She's thinking about it. All right. So mathing wise, really easy, but it's just new vocab that we have to worry about. That's where the vocab for all the vocab comes into play. Understand the vocab. All right. Same idea. Oh. if you look at this picture, don't draw this picture, let me just blow this up. If I'm just looking at this picture for right now, guys, if I'm just looking at this picture right now, knowing the two parts that you have, is that one dealing with angle bisectors or is that one dealing with perpendicular bisectors? Looking at the picture. Which of the two is it dealing with?
Are the sides of the triangle congruent or are the angles being bisected?
The angles are, right? That's what you have to be able to decipher. When you look at it, if you know that if you're dealing with perpendicular bisectors, you'll see tick marks on the edges, on the sides. Here you've got angles that are marked up. That means you've got to be dealing with that. Okay? Again, it's understanding what part you're working with. Gentlemen, please, enough. It's another thing is you just have to understand what you're working with. You understand what you're working with, mathing it super fast. So it tells you we've got 5x plus 36, 2x plus 51. So we set those two equal to each other. Excuse me. Subtract 2x, subtract 36. So we get what? 3x and what is that? 27, I believe? Not 27, I'm sorry. 15. Hello. Hi. Oops. All right. So I get 5. All right. Now, the question was, is it possible for QP to equal 50? Well, if we look at what we have here, if x is 5, that makes QN, this segment here, what is that, 61? And if you look at this, QP, guys, come on. Enough. QP in that little triangle there, is that a hypotenuse or a leg of that little right triangle? It's a hypotenuse. Can that hypotenuse be 50? Why? It's got what? Those are angles, not sides. Why can't this be 50? Why can't that piece be 50?
From what I say,
Sam, what do you got? Therefore,
triangle equal together. So he has to equal.
no, these are sides, guys. These are sides. The hypotenuse has to be the longest side. Okay? These are sides. These are not angles. Okay? So if this side is 61, across from the hypotenuse has to be something larger than 61, because the hypotenuse are always the longest side length. That's what it was getting at. Okay? The hypotenuse has to be the longest side length. Again, looking at this picture, are you dealing with an in-center or are you dealing with the circumcenter? The in-center. Okay? Why? Because you see all the bisecting of the angles.
Okay.
So take a second, solve for x. Okay? Okay, but if you're pointing at a side there, which it is, if it was perpendicular bisector, you'd have to have tick marks on the sides.
Yeah.
You see tick marks on the sides now. And that's where you're seeing
Yeah.
That's what I thought.
36. 2x. That's 36. What's 36? Easy. What'd you do? You went there.
Okay, so
So see, that means TV to TV, you have to do the same.
Gives you 2x, and then we have to add 24 to both sides. So negative 20. That's 12. Yeah, that's how we do it.
So I messed up with my negative all the time. I mean, it's like.
Subtract the 3x, add the 24. You guys get 6?
See, I got 18 because I didn't run. I forgot the negative.
Now, here's the thing. This happens a lot. Let's say you wrote it down. Did you write down with a plus by mistake?
No, I didn't write it down. I was writing it.
Oh, I got you. Because what happens a lot of times when people write down the problems, just by writing it, you just accidentally do a plus sign by mistake.
Yeah.
But then you math it all correctly, and it's correct, but it's just, you just wrote it down, you know what I mean? And that's why it's so important to show your work. That's why it's so important to do that.
And most teachers will still mark it.
All right.
Show your work.
I'm doing my work. I already think that's
And that's what I wanted you guys. That's why we always harp on you to make sure you show your stuff. All right. Again, try it again. Same idea. I like this one because it's got a little extra couple steps at the outset to make sure you work through it correctly.
Yeah.
Matt, we got right. Boom. Oh, wait, I gotta figure it out.
Yeah, Sammy. What's that? What's that? What do you mean? It's all the okay, when you're looking at that picture, remember that you have two types of triangles, right? We have two pieces. You have either what's called the circle or the inside. Okay. So what I'm looking at here is when you have the circumcenter, that's when it has all the particular bisector pieces. The in-center is when any bisector. So in this diagram, all the thing that we have shown to us is that we've got C up at angle M and angle L, how it's we got the particular bisector. That's what that's for. Whereas if it was the perpendicular bisector system, C minus N L, because that was just showing the angles. It means that in seconds, yes, it means that from those from that point where they meet, sides are all zero. So that means that RS and RT have to be the same. That's where the vocab is coming from by looking at the picture. Okay. We know that these guys are bisected, which means these segments have to be the same. Okay. So we get 4 times the quantity x minus 3 plus 6 is 5 times the quantity 2x minus 6. When you math that, you get 4x minus 12 plus 6, so you get 4x minus 6, and then 10x minus 30. Okay? Subtract the 4x, add the 30, we get 6x is 24. And you get 4. I asked you guys to figure out what RS is. So what's 4 minus 3? 1 times 4. And then add 6 and you get,
That's what. All right.
okay?
Right, this was it.
Oh, that's fine. You should still get the same answer. What's that? You did. So what's 2 times 4? What's 8 minus 2? 8 minus 6, excuse me. 2, what's 2 times 5? Okay. All right, that's what it's supposed to be. Yes, sir. What's 4 minus 3? What's 1 times 4? What's 4 plus 6? A sector, that's that. That's those. Got those all built in. Okay, cool. So, here's what I got. Once again, as I was saying, this stuff is relatively straightforward. There really isn't any craziness there. It's the idea that you follow the tick marks and figure out which of the two you're working with. I hope.
Thank you, my good man.
Yeah, that's it. What's wrong? She's the worst. So, on this sheet here, guys, you'll notice you either have, what's that? Oh, it doesn't matter. What I did was I kind of piecemealed together some of the problems that were within the textbook and some of the worksheets that it comes with, just so that way it's all in one sheet, makes it a little bit cleaner. As you go through, you just have to decide which of the two are you working with. Are you working with point to vertex? Or are you working with point to side to show that things are congruent? It works rather quickly as you go through. Let's see, what's the other piece there? I will say, actually it did show up. I will say that at the bottom of page 1, yes sir, that's fine. I will say at the bottom of page 1, that one larger diagram picture, I think I have it here.
Is that?
What's that? It is the circumcenter because it says the perpendicular bisectors meet. So what I would do right off the bat on this diagram, it tells you that these are the perpendicular bisectors, which means these are the parts. All those pieces are the same as you go around. And then if it's perpendicular bisectors, that means from the point to the vertex is the same. Okay? Point to vertex. Okay? That's where you get those. You will need Pythagorean theorem with that one. Just a little FYI, you will need Pythagorean theorem. Which you guys all know how to do, so it shouldn't be so bad. Alright? Okay. Ladies and gentlemen, you've got full almost 20 minutes. There's no reason for this not to be done before you walk out of here. It is really quick. Okay?